Okay, this is Algebra 2, Chapter 2, Section 1, Relations and Functions. Okay, so the first thing this section talks about is the concept of a relation. And a relation according to the book, is a set of pairs of input and output values. So a set, meaning group of input and output values. A set of input and output values. Input meaning things that you put into the relation, and then output is that outcomes that come from that particular relation. And according to the book, there are four ways. There are four ways to show a relation. So the first way, and you're familiar with the vast majority of the ways, actually. The first way to show a relation is using ordered pairs. You guys already know what that is. X and Y on a coordinate plane. So we have your input, which is always your X value, and your output, which is always your Y values. Got our X. And we got our Y's. And in that you can put whatever you want. Three, 4, 3, -1, 4, -1, 4, and 3. Alright, that is one way of saying a relation or showing a relation. Another way of showing a relation is something called mapping. In mapping, you have your input over here and your output over here. And you have your numbers. Notice that they're in number order. So -3, 3, and 4. They are in number order. Usually you put some type of surrounding over them. And you have your output. They should be in number order. I've always seen it in number order. This book is a little unique in that they put them in the order as they see it across. And that's something I don't usually see. But alright, let's stick with the book for consistency. 4, -1, 3. To show the relation, we draw the arrow from the output to the input. We draw an arrow from the output to the input. Yeah, that's one way of showing a relation. And the other way of showing a relation, and my favorite way, is to draw make a table. So the way that I do it, I do a T-chart. So you have our X, which is our input, we have our y, which is our output. And then we put in our numbers. 3, 4, 3, -1, 4, -1, 4, and 3. Just for me personally, this is the one that I use the most to show the relation. Quick and easy. And then the other way of doing it is by graphing. Graphing can show a relation as well. And I don't feel like graphing right now. But if I was to graph it, I guess I should show the graph. -3 and 4, 3 and -1, 4 and -1, 4 and 3. So it'll look like that. So that's another way of showing a relation. So ordered pairs, mapping, table, graphing. So the formula I give here is monthly average of water in the Gulf of Mexico and Key West for the average in months. So let's do this. They want you to show the relation in 4 ways, right? So we know that it's ordered pair, mapping, t-chart, or a table, or graphing. So let's call our input, right? Our inputs are x values, and we're going to call them the months. So we're going to associate the number for the month. So January would be 1, February would be 2, March would be 3, and April would be 4. So that's our inputs. Our outputs would be our y, and it would be our degrees. So the January degree is 69 degrees. Be Fahrenheit. February is 70. March is 75. And April is 78. So those are degrees. So the first way to do it is we can do it by ordered pair. And that would be 169, 2 and 70. So you guys see where I'm going with this. 3 and 75, and then 4 and 78. The next way to do it would be mapping. I'll do 1, 2, 3, and 4. Let's go 69, 70, 75, 78, which is neat that they're already in order too. And just draw your arrow. Like so. So that's 2 of the ways. There's order pair and there's mapping. Then there's a table. We can do the table. It's actually faster to do it with the eraser. So then there's the table, and that's my favorite one, my chart. So I have my X and my Y. 1, 2, 3, 4, 69, 70, 75, 78. And the other way to do it is to graph it. I'm not going to graph it, but I will label the axes. I don't feel like graphing, that's too much. So the Y is your degrees. Your X would be your months. So this would be like 1, 2, 3, 4. And you would have various, it would look like something like this. Upward going graph, more or less. So those are 4 ways to show that relation. Relations have something called domains and range. Domain, they are a set of x coordinates. Range, they are a set of y coordinates. Domain is a set of x coordinates. Range is a set of y coordinates. You can say it's a set of, you can say they're inputs, a set of inputs. You can say that the range is a set of outputs. Either way, that works. So notice that they said they're a set. So when we write what these guys are, we're going to put them in a set. So we have here, oh Jesus, these numbers. So when we do the domain, we do our little set and we write them. Usually the domain is in number order 3. They don't have to be, but usually they are. 9, 23. And then the range, again a set, so you put these brackets. They are usually in number order too, but I have also seen them the way that the book does them in order of the ordered pairs, but so I'll just stay consistent with the book. Negative 18 and negative 99. Alright, so that's how we write the domain and range. Okay. Function. A function is a relation in which each element of the domain corresponds, how do you spell correspond? To, no, one S. With exactly one element of the range. So normally I don't write definitions word for word. So that tells you how important I think about this definition. A relation, what a function is a relation in which each element of the domain is corresponding to or with exactly one element of the range. What does that mean? That means that every input has only one output. Every input has only one output. What that means is that I can't have one x value have two y values, but I can have two y values for multiple, or one y value for two x values. So let's see what that means. So they give us an example. Looking at example A, I have my -3 to -2, so that's exactly 1. I have 0 to 7, exactly 1. 4 to 1, exactly 1. Each domain has exactly one output, or one range. So that is a function. This one is not a function. If we look at it, we have 4 to -1. We also have 4 to 1. So I have one input, or one domain, with two outputs. I can only have 1 to 1. One domain can only have one output. One domain can only have one output. In this case, I have two outputs for one domain. This is not a function. Notice I didn't talk about the 8 and the 6. We can have multiple y's, the same y's. We can't have the same x's. So if you want to think about it that way, what you can have is you can have the same y values, or the same outputs. What you can't have is the same x values, or the same inputs. You can't have multiple 4s or multiple x's, but you can have multiple y's. That's fine. So this is not a function. Looking at number 3, they want me to know if this is a function or not. So I have a 2 to the 3, -3, and I have 2 to the +3. I have 3 to the -1, 4 to the 3, and 6 to the 6. This is not a function. And the reason it's not a function is because I have this x value 2 with multiple y values. I have multiple y values. So this is like the same 2 or the same x's. This is something I cannot have. I cannot have this. I can't have this x2 have two answers. It can only have one. B, this is a function. negative 7 to 14, 9 to negative 7, 14 to 7, 7 to 14. I can have multiple y values. I can have multiple y values. That's fine. As long as they have a separate x, which they do, then I'm okay. Another way to determine if something is a function or not is something called the vertical line test. And the vertical line test is usually deals with graphing, and the reason why it works is because it shows more than one x for a particular y. So the way to do the vertical line test, vertical is straight up and down, and you run it across your relation. And if you have a point where there's two x's existing at the same time on the vertical line, so it intersects twice, then you don't have a function. This right here is considered not a function because I have two x's or the same x for two different y's. This is a no-no. I can't have the same x. The easiest way to do it is to get like a pencil. Don't use your finger. Sometimes people's fingers, curve and they're bent and they're not straight. So use some type or a ruler would work out to use your vertical line test. So if we look at A, that is not a function. The vertical line test, you can see that it hits the function or relation rather twice. B, this is a function. It passes the vertical line test. This is an absolute value function. And C, this is not a function because it has two dots in the same intersecting the vertical line. So this is not a function. And if we look at a circle for guided letter A, and we do our vertical line test, zoop, that's not really vertical. Doot, neither is that. But they cross twice across the function, so that would be no, not a function. Then we have this guy over here. We have this thing. I'm not going to draw it exact, but I'll do the best that I can. And it's like around here. This guy would pass the vertical line test, so if I was to go like that, there's not going to be a place where I intersect multiple times. It passes the vertical line test, so I would say yes, this is a function. Then we have this guy that does something like this, and this guy would also pass the vertical line test. Every vertical line that I draw, it only hits it one time. So this would also be a yes sir. That's a function. So that's the vertical line test. Then we have something called the function rule. And what the function rule says is that if we have an equation represent the output value in terms, then you can write it out that particular rule. So the function rule is essentially the equation that represents the output. The equation that represents the output. Okay. And we also have something called function notation. I'm going to get to that in a second. So we have our y equals 3x plus 2, right? The x is my input value, and then the y is my output. Yay. Well, with function notation, we're going to take out the y, and instead of y, we're going to call it f of x. F of x, where we have a lowercase f and an x in parentheses. And that is going to be our output. And our input still goes in right here. So this is my input. And then this is my output. Okay? F of x. So when we want to solve for a function, we would put it in our function rule. So if they wanted to know what is f of 1, so what is my output when x is 1, f of 1, then wherever I see x, I replace it with 1. This is my function rule right here. My function rule is 3 times x plus 2, which gives me f of 1, where f of 1 is equal to 5. Okay. We have something called independent variables and dependent variables. Your x values are your independent variables. What does that mean? It means that I wrote VAR for variables. It means that I can put whatever I want in there. They're independent. They don't have to go through the function rule. So they're independent. My y values are dependent. I can't just put any random y into my, it depends on the function rule. It has to go through the function rule. Has to go through the function rule. While independent values, you could just make up stuff, 2, 5, 6, 7, 8. But for it to be the y, so let's go back to our initial one. It was f of x equals 3x plus 2. When I do this, I can choose whatever x I want. Negative 1, 0, 1, 2. I just made these up. But in order to find out what the output value is, I have to put the negative 1 in here, substitute it. Negative 1 and 3 is negative 3 plus 2, which is negative 1. This negative 1 only corresponds with that negative 1 here. I can't substitute any other number that corresponds to the negative 1 in the x value. This negative 1 went through the function rule to spew out negative 1. If I put a 0 here, I get a 2. Right? This 2 is only associated with that 0. It's dependent on the fact that I chose 0. I plug in 1, I get 5. I plug in 2 and I get 8. And I can only use 8. I can only use 5. I can only use 2. I can only use negative 1. The x, I can make up any one I want and plug it in here. Doesn't matter. So they give me f of x is equal to negative 4x plus 1. That's my function rule, and they want to know what is f of negative 2. So f of negative 2 is negative 4 times negative 2 plus 1, which is 8 plus 1, which is f of 2 equals 9. f of 0 equals negative 4 times 0 plus 1. So f of 0 equals 1. See where I'm going with this? F of 5 equals negative 4 times 5 plus 1. Negative 20 plus 1. F of 0, or 5 rather, equals negative 19. Okay? Writing a word problems. So word problems, just have to sort of rewrite them. I like to rewrite my word problems. So I'm buying sports bottles, and it says the cost is $1.19 for each bottle. So if I was thinking about this and what do I have and what does the problem want me to solve, I have that I have a bottle. I'm trying to buy sports bottles, so I'll put B for bottle. It cost $1.19 each. That each is important. Each is usually the clue that I'm multiplying. And they want to find the cost. What is the cost for 15 bottles? Okay. So we'll use the cost. So we'll say, instead of f of x, we'll say c of b. So the cost of the bottles. So the cost of the bottles is equal to $1.19 times b. So then the cost of 15 bottles will equal $1.19 times 15. And that gives me a number. And that number will be $17. Actually, cost of 15 bottles is equal to $17.85. Okay. So that is this section, introduction into graphing and stuff. So I hope you guys have a great rest of your day.